Nearly 5 decades after launch, Voyager continues to defy the odds in the outer reaches of the solar system. No one could have predicted that the program would become the longest running in NASA history. The probes have continued their journey uninterrupted until now. Data shows that Voyager 1 has made contact with an unknown object. This begs the question, is this object an anomaly or a sign of something more, perhaps even something intelligent? The Voyager program consists of 2 robotic interstellar probes called Voyager 1 and Voyager 2. They were launched way back in 1977, making them the longest space mission in human history. Their journey has taken them to the outer edges of the solar system, a feat no other craft since has achieved. Even though Voyager 2 was the first one to launch from Earth, the route it took to the stars meant it would be the second in the race to reach the heliosphere. The scope of the mission was to study the outer part of the solar system and gain knowledge about the outer planets and their moons. At first, the mission was quite simple. Voyager 1 had to study the planetary systems of Jupiter and Saturn, and Voyager 2 had to study Uranus and Neptune. The cost of the mission was around $865 million initially, but NASA later allocated at least another $30 million to keep the mission going. Currently, the Voyager space probes are exploring the outer boundary of the heliosphere in interstellar space. As a result of their success, the mission has been extended 3 times as they continue to transmit useful scientific data. It was confirmed that on August 25, 2012, Voyager 1 had become the first man-made object to exit the solar system and enter interstellar space. The probe is currently rising above the ecliptic plane at an angle of about 35 degrees at a rate of about 320 million miles a year, or around 10 miles a second. The Voyager program used the favorable alignment of Jupiter, Saturn, Uranus and Neptune, which occurs only once every 175 years and was set to happen in the late 1970s. The probes used gravitational assists, namely the use of the relative movements and gravity of a planet or other astronomical object to alter the path and speed of a spacecraft, and thus saving propellant and reducing expense. Through gravitational assistance, it's possible to either accelerate a spacecraft or decrease its speed or redirect its path. While Voyager 2 was launched first on August 20, 1977, Voyager 1 was launched on September 5, 1977 on a faster and shorter trajectory. Originally, the probes were to conduct close-up studies of Jupiter and Saturn and their larger moons. As this mission was a tremendous success and the probes were in good condition, scientists decided to go and explore Uranus and Neptune. The Voyager probes made it possible to recover a lot of data and photographs of the most distant planets, thus allowing scientists to have precise details which were until then still unknown about the 4 giant planets and their moons. Voyager 1 made its closest approach to Jupiter on March 5, 1979, when it came within 172,368 miles of the planet. The probes were able to observe Jupiter's cloud forms and its wind and storm systems, as well as to discover the volcanic activity on its moon Io. It was the first time that active volcanoes have been seen on another body in the solar system. Plumes from the volcanoes extended to more than 190 miles above the surface. Saturn is the second largest planet in the solar system, and it takes 29.5 Earth years to complete one orbit of the Sun. The planet is known to have at least 17 moons and a complex ring system. It was also discovered that 7% of the upper atmosphere of Saturn is helium, and the rest is hydrogen. Titan, Saturn's largest moon, was also studied. Titan is the second largest moon in the solar system at 3,200 miles in diameter. That makes it around the same size as Mars. Among the major discoveries was the discovery of a magnetic field around Uranus and 10 of its moons, but also the discovery of 3 rings and 6 unknown moons of Neptune. Furthermore, Voyagers 1 and 2 sent us a lot of close-up photos of the giant planets. Among them is the pale blue dot, taken in 1990 by Voyager 1. This famous photograph pictures planet Earth from a distance of about 3.7 billion miles. planet Earth appears as a very small blue dot, lost in the vastness of space. As the main mission of the Voyager program was achieved in August of 1989, when Voyager 2 flew within 3,000 miles of Neptune, it was decided to extend their mission and rename it the Voyager Interstellar Mission. The goal was to extend the exploration of the solar system beyond the outer planets and, if possible, beyond the limits of the solar system, beyond what we call the heliopause boundary. It can be defined as the limit where the solar wind from the Sun is stopped by the interstellar medium. Reaching after the heliopause will allow the space probes to make measurements of the interstellar fields, particles and waves that are unaffected by the solar wind, and thus providing scientists with invaluable data. Exactly where the heliopause is has been one of the great unanswered questions in space physics. By studying the radio emissions, scientists now theorize the heliopause exists some 90 to 120 astronomical units from the Sun. As of today, the probes continue to send important data back to Earth. Currently, they mainly study ultraviolet sources among the stars, and they explore the boundary between the Sun's influence and interstellar space. Recently, Voyager 1 made headlines when it picked up the signature of interstellar space itself, a faint plasma hum that experts have compared to gentle rain. This discovery came at a desolate part of the solar system around 14 billion miles away. Plasma has been part of the Voyager 1's mission from its launch. The spacecraft discovered lightning strikes in Jupiter's atmosphere and studied how the solar wind tapered off in the outer solar system. Since 2012, scientists have turned the spacecraft instruments upon a completely unexplored part of distant space. That's when Voyager 1 crossed the heliopause, where the solar wind, the constant stream of charged particles that flows off the Sun, is no longer strong enough to hold back the interstellar medium that surrounds our little neighborhood. As Voyager 1 drifted even farther from the Sun, the spacecraft measured the plasma around it. This part of the interstellar medium is mostly quiet. It's very faint and monotone because it is in the narrow frequency bandwidth. But every few years, the solar wind pushes back. Voyager 1 picks up those events as shockwaves. For a time, scientists thought those shocks were the only way that Voyager 1 could measure the density of plasma out there. But now that scientists have heard this unexpected hum, they can track the interstellar medium between shocks, which can help them understand much more about a largely undiscovered expanse of space. Scientists believe there's much more low-level activity in the interstellar medium than they previously thought. This discovery means that now we know we don't need a fortuitous event related to the Sun to measure interstellar plasma. Regardless of what the Sun is doing, Voyager is sending back invaluable data about this plasma. It is detailing the density it is traveling through and records the change in the space around it. Although the probes are still transmitting data back to Earth, their age may finally be catching up with them. For one, it now takes much longer for the craft to collect information from their surroundings and send it back home. However, this is something NASA anticipates. After all, it is quite surreal that the probes are still functional after several decades of degradation in space. Scientists are more concerned about the health of the probes and their ability to collect reliable data. Now located around 15 billion miles from Earth, Voyager 1 has recently sent back some confusing anomalous messages. After running tests, NASA discovered that the probe was having a hard time with its attitude, articulation and control system, which controls its trajectory and orientation. This system is crucial as it keeps Voyager 1's high-gain antenna pointed straight toward Earth, enabling it to send data back home. All signs point to the fact that the probe is still operational, as it has not entered safe mode. NASA has stated that problems such as these are expected given the craft's age. However, scientists are still intrigued by the data Voyager 1 has sent back, as it suggests that the craft may have made contact with an unknown object. This could be anything, ranging from space debris to a gas pocket, or it could be something far more advanced. Due to the corrupted data, there is no way to know for sure, but it is a terrifying thought that an object heading toward our solar system made contact with the probe. To make things worse, it now takes an entire day to communicate with the craft given the massive distance. This has made it even harder to interpret this anomalous data to try and fix the probe. Initial diagnosis reveals that the malfunctioning AACS may be responsible for these invalid messages, as the data could have been corrupted before it reached home. But there is no way to know of how much it is invalid. The confusing thing is that no one at NASA can explain why the probe started acting strangely, as there was no prior warning that the AACS was deteriorating. NASA has since reoriented the craft and has found that it is still completely operational. This has raised speculation that the probe may have come into contact with something that made it change its trajectory. The only other explanation is that the Voyager experienced a glitch for the first time in almost 50 years of flawless operation. Although these events are hard to explain, there is no denying that something strange happened to the probe that day. What it was is something we may never know for sure. One thing is for certain: if the probe was contacted by forces beyond our understanding, we may have a second chance of communication when the Voyager 2 eventually passes through the same area. But in the meanwhile, we must ask ourselves, was Voyager 1 a victim of alien interference?